Hi everyone. Welcome to this presentation on Point E, a system for generating 3D point clouds from complex prompts, authored by researchers at OpenAI. Today, we'll introduce Point E, a novel and efficient system for creating 3D models from text prompts using diffusion models. So just to start with an introduction, the main problem that Point E aims to solve is the inefficiency of existing text to 3D generation methods. Most current approaches require multiple GPU hours to generate a single sample, making it difficult to apply in practice. In contrast, Point E generates 3D models in only 1 to 2 minutes, making 3D content creation more feasible for applications like VR, gaming, and industrial design.
Current text to 3D generation methods generally fall into two categories. You have text to 3D models, which are trained directly on text to 3D pairs or unlabeled 3D data. And the pro is that you can generate these 3D samples quite efficiently, but it's hard to scale these to diverse prompts because there's generally a lack of available 3D datasets. For image to 3D models, you can leverage pre-trained text to image models and then optimize 3D representations on those images, which can lead to a good, diverse, and complex prompt representation. However, it's computationally expensive and can be hard to optimize, causing incoherent generation.
Now let's look at how the data flows in Point E. The input is a simple text prompt, like a corgi. First, a synthetic 2D image is generated from this text using a text-to-image model. This image then serves as input for generating the 3D output, a colored point cloud, which is a set of points in 3D space representing the object's shape and color.
The architecture behind Point E involves several advanced components. First, the glide model, which is a 3 billion parameter diffusion model, which generates a synthetic image based on the text. Then, for generating the 3D point cloud, a diffusion-based transformer model is used. It leverages a pre-trained clip model to extract embeddings from the synthetic image, which are fed as conditioning tokens to the transformer. The point cloud diffusion model represents each point cloud as a k times 6 tensor, where k is the number of points and each point contains XYZ coordinates and RGB color values. This diffusion model denoises random noise in an iterative process to generate the final point cloud. Additionally, an upsampler model, also transformer-based, refines the initial low-resolution point cloud from 1,024 points to a high-resolution version of 4,096 points.
So let's break down the workflow into specific steps. Step 1. The text prompt is processed by Glide, generating a synthetic 2D image. Then, for step 2, this image is encoded using a pre-trained clip model, producing image features as conditioning tokens. Step 3. The diffusion transformer model then generates a coarse point cloud based on these features. And finally, step 4. The upsampler takes this coarse cloud and adds more points to enhance resolution. This combination of image to 3D and point cloud refinement is what allows Point E to generate results quickly.
Moving on to the results, the team evaluated Point E using several metrics, such as clip R precision, which measures how well the generated 3D models align with the text prompts, and PIS and PFID, which measured the quality and diversity of generated point clouds. Although Point E's quality is below the state of the art, it achieves significant computational speedups, requiring only 1 to 2 minutes per model compared to hours for other methods. In this diagram on the right, we can see that the latency for our Point E models is significantly faster when converted into a comparable GPU metric.
So let's look at the results in more depth. Point E can produce consistent and high-quality 3D shapes for many prompts, but it sometimes struggles with very detailed or complex prompts. These limitations mean that Point E may be best suited for rapid prototyping rather than high-quality production rendering. It still opens up exciting possibilities for applications where speed is a priority.
In conclusion, Point E offers an exciting leap forward in text to 3D synthesis. By leveraging a novel combination of a text-to-image diffusion model and a transformer-based point cloud diffusion model, it can generate 3D models in minutes rather than hours. This efficiency makes it a practical tool for a variety of fields, from gaming to industrial design, and offers a strong base for future improvements in the field of 3D content creation.
Finally, we'd like to thank the authors of this paper and OpenAI for making the models and code accessible to the community. You can explore the resources and even try out Point E for yourself at the GitHub repository linked here. Thank you for listening.